Look at the screen. How many dots? And here? What about now? Your brain processed those quantities before you even had a chance to consciously count them. Cognitive scientists call this subitizing, the brain's innate ability to instantly recognize small numbers at a glance. Most societal assumptions treat math as an invented system, painstakingly taught in a classroom. This hardwired instinct for quantity exists in your brain before you even learn to speak, raising a question about where mathematics actually comes from. This instinct lives in a specific number module within the parietal lobe. This hardware functions without the need for language, and research shows it is already active in pre-verbal human infants. Wild animals use this same biological circuit. It allows a predator to estimate the size of a rival group, or a bird to choose the branch with the most berries. However, this biological hardware has a strict limit. The human brain can only process exact quantities up to 3 or 4 using this reflex. Past that threshold, the brain shifts strategies. It stops tracking individuals and starts providing a rough sense of magnitude. Humans share a baseline survival math with the rest of the animal kingdom, though our biological hardware is strictly limited to these small, exact quantities. This creates a contradiction. Our species is biologically capped at the number 4, yet we manage to build cities and navigate to the moon. Ancient humans bypassed this limit by inventing abstract symbols. Digits like 1 through 9 allow us to represent the exact quantities that our brains cannot visualize instinctively. Symbols and language act as an expansion pack for our biology, hooking into the number module to extend its reach. Learning complex mathematics in school is essentially a process of training the brain to map these cultural symbols back to that primitive parietal lobe instinct. Higher-level mathematics takes an ancient biological instinct and scales it through the use of human culture. The reality of this physical math center is visible in the pathology of dyscalculia. Dyscalculia causes a form of numeral blindness. The concept of exact quantity fails to cohere in the mind, even when looking at a simple cluster of objects. This condition is highly specific. People with dyscalculia maintain normal intelligence and often demonstrate high proficiency in writing, logic, and the arts. This isolated failure demonstrates that the math module is a distinct physical structure in the brain, separate from our general ability to learn or reason. Because mathematics has a dedicated physical failure point, it exists as a biological reality rather than a general measure of intelligence. This changes how we view the common phrase, "I'm just not a math person." Every healthy human brain contains the specific parietal lobe hardware required to perceive quantity. Difficulty with calculus or algebra often stems from a translation error between these complex cultural symbols and the primitive hardware underneath. Mathematics is a biological lens, a system we are physically designed to use when perceiving the physical world. Beneath the cultural anxiety and the symbols, every human being possesses a brain built to understand the language of numbers.